Sometimes that's what we want because we are counting how many of such, came out in the table. But sometimes we are processing these and we don't want repetitions. So in those cases, we insert a distinct word there. We want the end result of this column. And if we have more columns, the column, comma, column, the entire row is distinct from each other. The entire row. Our row consists of one column. But if we have multiple columns, then the entire row needs to be distinct from one another. So oftentimes, if you look at some sample codes, you find that there are quite abundant use of distinct. It's a bit of an insurance there that if you actually pull in a few tables like this, especially when they are the same table, so account used as T1, account used as T2, and that's quite common. Huh? So when you pull in the same table as two names, you tend to, all right, whether you like it or not, you tend to encounter this kind of repetitions very easily. So as a sort of insurance, we just put in the distinct just to make sure that the rows will be distinct. However, don't abuse it. Like I said, there are times where we are counting such repetitions, and that is exactly the non-distinctness is exactly what we are after. Then it'll be totally wrong to do a distinct. Yeah. So these two parts, the only difference is the distinct word to see or illustrate uh, the distinction between the effects of distinct here. And then the next query is to throw in a little bit more variety. All right, but you should find that it is not really that confusing because let's suppose we want a long name. So we'll take the name and the first four characters starting at position 1, 2, 3, 4, extract the first four characters of name and join it with equal equal, and then join it with the first 6 characters of the name. Yeah, and then call that long name. And then call that long name. From account 1 as T1, account as T2. So in other words, we're getting full permutation of first 4 and last 6. First 4 and last 6. We're getting full permutations. But suppose we don't want to see everything, all hundreds of them. We just say where length of T1 name is greater or equal to 20. Because if the length is only 2 characters, 1 character, this substring may fail, right? And we want T2 FR type to be like BS. So it is sort of a balance sheet kind of names associated with balance sheet. So this is an and, right? These two requirements must be fulfilled before we perform this extraction. So virtually we have all permutations, but then we filter off where only T1 name is longer than 20, then we take. Then from the remaining results, we further say T2 FR type must be BS. Then we see how to combine them. Oh, we do this linking with an equal equal and so on. So end result is we only get 5 rows. Okay. And let's look at our account table. So over here, we have the original setup of 10 rows. Yeah. And T1 name simply is the same as name, right? So T1 name bigger than 20 probably just means this. And the second longest is loan for 12, 13, 14, 15, 16, not even 20. So the longest string is logistics and transport. So that limits to basically this case. So T1, right? T1 name. So on the left side is this table. On the right side is also this table. But we want the left side to be narrowed down to all rows starting with logistics and transport. Okay, so that will do that. Then if we don't say anything else, we will get 10 rows because it will be logistics linked with what is it? The FR type, which is PL, BS, right? So logistics BS 5 times repeated and so on. FR type. No, we are going to link with name. So logistics equipment, logistics bank, logistics inventory, logistics loan, logistics capital. Keep doing that, except we extract the last 6 characters. No, the first 6 characters, sorry. Right, so but we don't want all these. We want furthermore T2 FR type to be like BS. So T2, which is the same table, FR type, which is like BS. So it will be these 5 rows. these 5 rows. So end up we'll get only 5 rows where we get the first 4 characters logi, then equal, the first 6 characters equip m, then bank space dash, then invent, then loan space dash, then capita, and that's all. Yeah. So let's just check. In fact, that is exactly what we have. Okay, I hope you follow the logic. Now up comes our actual battleground in Spider, right? So let's go to Spider. Let's create a new script and copy all the 3 sections from our previous script. If you just jump in and join us and you haven't got all the previous scripts, don't worry, because this is the yellow section, the opening section where we import and make a connection to the database. This is mandatory. The last section is to close the cursor, close the connection. Not really mandatory, but definitely a good practice to keep. So I would just insist that you try to keep this. And in the middle is where we obtain, first of all, a cursor and then do all the execution of SQL commands. So let's begin with the select. Okay, so we perform a select T1 FR type and linked with T2.subtype, right, as long description. So we call this column long description from account as T1, comma, account as T2. So that will give us 100 rows. Then we will select again, and this time round we copy and pasted. As you see, I copy and pasted, and just insert the word distinct. Yeah. Okay, the rest I'm not going to move them and change them. Just insert the word distinct here, and that's all. Okay, and in the third execution, we will perform a slightly longer select, but hopefully nothing very intimidating. We perform a substring of t1.name 1 to 4 linked with equal. You can change this if you like. Substring t2 dot name comma 1 comma 6 as long name. Yeah, so we do that from account as t1, account as t2, and we put in some conditions here, right? Where length of t1.name greater equal to 20. This ensures that our left-hand side, not right-hand side, left-hand side only, pulls out only the logistics row. And right, and then we further limit the right-hand side, t2.fr type like bs or equal to bs, and that is basically all. All right, so we print it out. Is there something wrong here? T2 subtype. Okay, there's some flagging of red color here. Unexpected indent. Okay, something is wrong. So over here, yeah, because I have extra closing triple quotes there. Okay, it looks nice. So let's run it. Yeah, and what's going on? Because we have no such table. This happens in line 21. T2.subtype as long description from account. Oh, yeah, because I copied from the test01. Sorry about that. Okay, I think we are ready. Let's run it. This is ugly. Let's start a new shell. Okay, let's run it. Okay, so for the first display, my shell can hold 1,000 lines. So fortunately, it is able to absorb all these, right? So we can force it to single column. And you see that this is basically repeating, right? BS equals to S at BS. So by permutation, even if the content is repeated, cross product basically just mechanically permute them and join them. How do I know it's cross product? Well, because comma is just cross producting with the next table on the right. Yeah. So when we do this, we have a lot of repetitions, and if we don't want them, we want each row to be distinct, right? The entire row compared with the entire row equals. So remove the duplications. So that is achieved by saying distinct. So this produces the second set of results, which gives us how many? 10. Yeah, so these are distinct rows because BS asset is not the same as BS liability and so on. So we do get distinct. It's not to say that the first result is wrong. Like I said, the first result, sometimes we want to count how many occurrences or repeatedness for each distinct row. For example, if we want to perform group by on the first result, it is meaningful. If we perform group by on the second result, it's wrong because we will get one row per group, and that's usually not what we are after. There's no aggregation. Aggregation is the content of that row itself, right? The lone row itself, and that's wrong. So if you see distinct followed by group by, then something is wrong. Yeah, because we expect some uh, sort of multiplicity, some count of rows within the within each distinct value. And finally, we also perform a more complicated select where we extract lines. We extracted portions of the names, and then we actually cross product with itself, right? So we are trying to get all permutations, but then we kind of nipped off on the left side by name, the length of characters, but on the right side is a different criteria, and I say the right side by using T2. So it's very clear, right? Even though we are operating or playing around with the same table on the database, we have two virtual names to the same content, and we can just think of T1, T2 as two tables. So left side I want, so T1 I want this, T2 I want that, and we end up getting what we want here. Okay, so hopefully you see the complicated selects from here on as pretty logical, simple, and necessarily so. So then it makes you much more versatile and capable of analyzing complex select situations. See you in the next video.